Oscillation chopper. The difference from the two previous choppers is that there is no saturable reactor or auto transformer in its load circuit as they are in Morgan's and Jones chopper respectively. It gets its specific name as oscillation chopper due to the resonating or oscillating nature of the voltage commutated chopper or class D commutation, and its switching mode is similar to that of the Jones chopper, and it has higher frequency switching. Let us see the working of oscillation chopper. The working of oscillation chopper is almost similar to Jones chopper. So in mode 1, when main thyristor T1 is on, the supply goes to the load R1 L1. So the current flows from VDC plus to T1 to R1 L1 back to VDC negative. At the same time, commutation capacitor C discharges current IC through the thyristor, main thyristor T1, and current path is C plus to T1 to R1 to L1 to VDC minus. Due to the flow of the capacitor current, C charges in reverse direction through the resonating circuit at plus C to T1 to R2 to L2 to D to C minus. Now, before we turn on the main thyristor, the capacitor voltage VC is at VDC plus. Now, due to this resonating circuit, the capacitor reverse charges from this side. So now it became VDC minus. The lower plate becomes positive and upper plate becomes negative due to the reverse charging. Due to the presence of this diode, C retains in same voltage until auxiliary thyristor TA turns on. Now mode 2, where TA is fired. As soon as TA fires, VC starts discharging in this direction. Then the current flows VDC plus to C to TA to the load R1 L1 back to VDC minus. Due to this, the T1 is going to turn off. As soon as the voltage of the capacitor C becomes 0, the thyristor TA also turns off. Again, the capacitor is going to charge from the supply and becomes VDC positive. And this cycle of oscillation commutation capacitor is going to happen in every cycle. The load is an inductive type. It stores energy. When T1, T2 are off, the load releases its stored energy through a freewheeling diode DF, and it is connected across the load. This is how the oscillation chopper works. Now let us summarize this. When the supply is given, the commutation capacitor is going to charge up to the VDC plus. When main thyristor is turned on, the supply is given to the load R1 L1. At the same time, the capacitor C is going to discharge through the T1 as well as reverse charge to minus VDC through R2, L2 and D. And it retains at minus VDC due to the D presence in this circuit. When the auxiliary thyristor TA is turned on, the commutation capacitor is going to discharge through the auxiliary thyristor TA. While doing this, the voltage at this terminal will be more than T1 turns off. When VDC discharges to 0, the auxiliary thyristor is going to turn off. When both thyristors are turned off, due to the inductance presence in the load, it is not going to allow the sudden changes in the current. Is going to apply the current through the freewheeling diode until the main thyristor turns on. Meanwhile, the capacitor is going to charge up to the VDC. This is how the oscillation chopper works. If you feel this video is useful, please like, share and subscribe.